4, 5, 6. Okay, skipping all this working and straight get the characteristic equation. So when you solve this, okay, this implies y1 equals to e the power of negative 1 over 3 x. Where you get this is from here. Y
Yeah.
equals to mx. Huh?
Yeah.
And
Right.
2 equals to e to the power of negative
Negative
x
x
are
solution.
solutions. This implies, since these are two linearly, not only solutions, linearly
Independent.
independent solutions. So this implies y equals to, you put one arbitrary constant, a e the power of negative x plus b e the power of negative x is the
General solution.
general solution. Okay, so now you're going to use the same concept for this equation. Okay, now it's not y but it's u. Okay, so this you go to tutorial 4, question 3. Yeah,
Yeah.
this u equals to u xy. Okay,
Yeah.
ux is del u del x lah, correct?
Yes.
And uxx is equals to del squared u del x.
Square.
Okay, so you go back to this theory behind coordinate. Okay, how do you find del u del x? By assuming the functions in y are constant.
Constant.
Okay, here m is a constant,
Yeah.
correct? So you get this and this. So using the same theory, uh, let u equals to same, compare with this, e to the power of mx, e to the power of
Fy function.
yeah, f y
X.
x be a
Solution.
solution. This implies u x equals to
Fy exponent Fyx. Fy square. Exponent Fyx.
okay, same. Okay,
Yeah.
then you substitute inside, inside the original equation, you get what?
2 Fy square.
2 f. I don't write the fy lah, f squared lah.
Okay.
Just e to the power of f x minus
For Y F
4y
F
is
exponent
plus
Y square. Exponent Fx.
Okay, also got e to the power of fx. Huh?
Mm-hmm.
So e to the power of f times fy times x times by 2 f
To f
squared.
squared minus 4y f
Oh, f
f
plus y squared.
y squared.
Okay, same again, same
Yeah.
idea. E to the power of fx cannot be 0. It must be always be
0.
positive. Huh?
Yes.
Implies 2 f minus 4yf plus y squared equals to 0. Okay. So
0.
you want to find f lah.
Yeah.
Correct. F is a function in y lah.
Yes.
That's why you can get the function y, all these are still function in y. You can cancel, get 0 lah. So
Yes.
you can, you know how to factorize,
Betul.
you
Yeah,
know how to
yeah.
factorize, or you can use a completion of
Uh-huh.
okay.
Understand.
So
Yes.
yeah, so this implies f squared minus 2y f plus half y squared equals to 0. Okay, completion of squares, or you can put use the negative b plus minus square root of b square minus y is you prefer.
Uh, put yeah, completing the square.
Completion of squares. Okay, so f squared minus 2, I put the f y plus y squared equal y squared minus half y squared. Okay, this half y squared I bring to the right. This y
Yeah.
squared I put it because I want to complete the square lah. A squared minus 2ab plus b squared. You can factorize a squared minus 2ab plus b squared is actually equals to a minus b squared. Right.
Right.
So
Yes. Yes.
here the a is f lah minus y
Y
squared equals
squared
to half y
half
squared.
y squared.
So f minus y equals to
Plus minus
uh, plus minus y over
square root 2.
this implies f is fy lah y
Yes.
plus minus y over square root 2.
Square root 2.
So this implies your there's one lah f1 y is equals to no no
Doctor,
no.
can you please? Yeah, okay.
Okay, this implies this is like the m1 lah. The m1 is y plus y over square root 2. M2 is y minus y over square root 2. Okay,
Yeah. Yeah.
therefore the u xy equals to e to the power of must times is x lah, x y plus xy over square root 2 some function, some not arbitrary constant, but arbitrary function in arbitrary function in
XY.
no
Y
y
only.
only because the u del x what del u del x is treating the functions in y as a constant. Okay.
Oh,
Yeah.
yeah.
The
Yeah.
earlier you saw for the ordinary is just a constant lah. Here
Mm-hmm.
partial differentiation with respect to x is treating all the functions in y as correct.
Yes.
So you got your e to the power of xy both here lah. E to the power of xy uh, a e to the power of xy over square root 2
Yeah.
plus b e to the power of negative xy over 2. Function in y lah.
Yeah.
So this is the solution. You can leave it like this, but you can also use the what?
Cos and sine.
Yeah, cos and sine. Okay,
Yeah.
so you know the cos is a linear combination of this and this e to the power of xy over square root 2 and e to the power of negative xy over square root 2. Sine also is a linear combination of e to the power of xy over square root 2 and e to the power negative xy over square root 2. Okay, so you're changing from arbitrary constants a and b to c and d lah. Cos xy over square root 2 plus dy
Sine.
sine xy over square root.
Right.
Okay,
Yes.
Doctor,
yes.
I am a geek about why we have to put a in term of function of y. Why not x?
Which one? I can't. This one is it? A is function in y, is it?
Yes, yes.
Okay, good question. If u I equals to let's say ax e to the power of fy x. Okay, what happens to ux?
Fy. Exponent fyx
That's all.
plus a prime x exponent fyx.
Yeah. So we didn't do this. We can't. We won't. We'll be getting this.
Yeah.
But if ux to a y in the power of
FY
fy x ux equals to
AY exponent exponent FYX. Yes.
correct. That's all. Okay, so every uxx also will have the a but fy squared lah
Doctor,
e
you
to the
can
power.
see. Okay.
Okay.
Yeah.
Yeah. Then when you substitute into the when you substitute this into the original equation, you'll find that this is the solution. Okay. 2 because everything got the a.
Mhm.
Okay. Also got the ay. So you got the ay. 2uxx. Ay fy squared e to the power of fyx minus 4y fy e to the power of fyx. Are you following or not?
Yeah.
Yeah, all this, everything got the ay. Okay, then you can factorize and you can cancel off.
Yes.
Like, no fy, e to the power of fyx. Okay, so you see,
Doctor, why
no,
there
no,
is
no,
two?
just two is here.
Okay.
Okay, so this implies that you got the ay e to the power of fy x also common lah. Then you are
Mm.
left with y squared.
Two.
2
Yes.
2 fy squared minus 4y f
Y.
this 2 is outside. 2 fy squared. 2 fy 4y fy y
Square
squared
equal to 0.
equals to 0. Curly bracket.
Yeah.
Correct. So
Yes.
ay can be anything lah. It still be if because we choose the uh, y plus no fy is what? Yeah, y square root 2. We choose y plus y over square root 2. Okay. And if you choose y minus y over square root 2, you put this inside. You put this y plus y over square root 2 square. 2 minus 4y.
Doctor.
Sorry.
Okay.
Okay. Y plus y over square root 2 plus y squared. What do you think you're going to get?
Wait.
These are the roots of this quadratic. This is one of the roots of the quadratic.
0.
Yeah, you sure you get 0.
Yeah.
Yeah, guarantee because this is one of the roots of the quadratic equation. Okay.
Yes.
Yeah, sure. Guarantee equals to 0. So this satisfies, huh? If you choose AY, but if you choose AX, because you got the A prime,
Yeah.
you find the del squared U del X squared, you're going to get some more A double prime X and A prime X and AX, all this you put inside. You're not going to cancel and get 0.
Yes.
Okay, so that's the reason why it is AY. But the background concept behind this is because for the ordinary differential equations, ordinary differential equations constant, where A, B are
Arbitrary constant.
arbitrary constants. Okay,
Yes.
yeah. So that is because, yeah, all these are constants when you when you differentiate lah. But here, when you find del u del x, you need arbitrary functions in y, but not functions in x. Functions in y only treated as constants. Functions in x not treated as constants. Same. A y here, they'll be treated as a constant. Correct. If I put
Yes.
a y here, okay. But if I put ax, it won't be treated as a constant. If I put ay, treated as a constant. Okay.
Yes.
Yeah. So that's the background lah. Okay. So more questions?
That's all for me.
Okay. Good. Okay. Happy that studying and asking questions and good questions lah. Wrong questions. Okay. So you know how to change from here to here, right?
Yes.
Yeah. Okay. So now what's the time? That's the clock. Oh, 9:41, is it? 9:42. Hey, 2. My clock is stopped already. 2:42. Okay, some more question. The other questions, no problem, huh?
Yes. No problem.
5, 6, no problem. Huh?
Yeah.
Okay, so uh, just overall summary. This is a direct question. 1 is direct solution using the theorem. Okay, and then D'Alembert's method. Question 2 and 3. Mm,
Yeah, doctor. I want to ask for the question one. If I just do it until exponent doesn't change it to the sign and uh
Kasha,
cos h.
can.
Okay.
Yeah, you put the e to the power negative x and positive x can.
Yeah. Okay.
Unless the question asks you lah. Okay, so yeah, first one is using the theorem. Just actually directly using the theorem lah.
Yes.
Second one and third one that you just did, treating them as like ODE, comparing them with the ordinary differential equation. And then
Yes.
wherever you know the one ordinary differential equations, you use constants. You have functions in PDE lah. When it's del u del y means the x function in x becomes a arbitrary. If del u del x
Yeah.
del square u del x squared, then the functions in y become the constants or arbitrary
Understand.
constant. Okay. Yeah.
Yeah.
Mm. This one is using the theorem lah, directly using the theorem, and yeah, then using the initial condition lah, I think lah. Question 5 and 6 is question 5 is using the theorems. Question 6 is using the variation of parameters method.
Yes.
Okay, so that's it. So I see you all at 4. I'll wait for a while in case there are some more questions. No,
Doctor,
yes,
can I ask for tutorial 2 question 3 for particular solution
tutorial.
for part
Wait, let me refer to it. Tutorial 2, question 3. Solution, correct? Okay. You want to use variation of parameters method, is it? Hello? Hello?
yes,
Wow.
I just confused for AT plus B and CT plus D. Confused for that part.
So let me check the solution. Question 3, huh? You mean we're using the method of undetermined coefficients, is it?
Yes.
Is it?
Mm-hmm.
Oh, let me get the. Which one? This one, this page, is it?
Yes, correct. For
Which one?
AT plus B and CT plus D, I just curious the
Okay.
theory behind this. How to get why it works like this. Okay.
Why like
Uh-huh.
this? Because this is because the question in the question itself is 2 2t times e to the power of 2t. the non-homogeneous part. Okay. Can you see the question? The non-homogeneous part is made of 2t times e to the power of 2t. Are you following what I'm saying?
Okay.
Okay. 2ta is a polynomial of degree 1.
Okay.
Yeah. So you have 2t means polynomial of degree 1, you must have a polynomial of degree 1. Well, what polynomial of degree 1? You don't know. So this is a general polynomial of degree 1. At plus b. It's a general polynomial of degree 1. You know what's polynomial, right?
Yes, no.
Yeah. So this is a polynomial of degree 1. Question itself is the part that makes it the non-homogeneous is 2t e to the power of 2t, which is a polynomial of degree 1 times by e to the power of 2t. So you must have the same form. Okay? Okay or not?
Okay, okay.
Yeah. That's why you put this.
Doctor, in
Yes.
chatbot, have a question for tutorial 1, question 6b from Nura Atika Zaharim.
Pardon? What is that?
The question, there is question in the chat box asked by Nura Atika Zaharim.
Chat box, sir. You mean the WhatsApp, is it?
In this Google Meet.
Oh, I see. In the in call message, is it? Tutorial 1, question 6b. How you get V1, V2, V3. Tutorial 1, question 6b. Tutorial 1, six B. Ha. Oh yeah, my things are all messed up already. All I had to put back, otherwise I'll get all my things will be gone already. Uh, 6. 6. Tutorial 2. Okay. Tutorial 1, question 6B. Okay. Oh. Oops. 6B. So this question, 6b. Yes, v1. Oh, there. V1, V2, V3 are the entries in this vector, eigenvector, correct? Hello? Hello? Hello?
Yes.
Okay, yeah. V1, V2, V3 are the entries in this eigenvector, V. Okay. So they must satisfy this equation, this times V1, V2, V3, this matrix times by V1, V2, V3 equals to 0. So when you first row times by this, you get this. Second row, you get this. Wait, you can't see already. Huh? First row times by this vector, you get this. Second row, you times by this vector, you get this. Okay. So you want to get nice numbers for V1, V2, and V3 lah. Problem lah. So when you write V1 in terms of V3, okay, you can choose because there are two equations and three variables V1, V2, and V3. Three. So one of it you can choose anything other than 0 lah. So since V1, V2 both can be written in terms of V3, you choose. Okay, we are going to choose V3. But V3, if you choose randomly, let's say we choose V3 is 1, so then V1 we are going to get square root 2 over negative square root 2 over negative square root 2 minus I. Then we have to simplify that some more. Okay, same. Then from V2 is negative 1 over 1 minus square root 2. So we don't want to choose simply randomly. So since whatever we choose for the V3, then you're going to divide by negative square root 2 minus I. We are also going to divide by 1 minus I square root 2. We purposely choose the V3 as a product of these two coefficients. So we choose V3. Product means not necessarily exactly negative square root 2 minus I square root 2 plus I. And 1 minus I square root 2. I don't know whether that helps or not. Okay. So this is how we choose. You see, V1 is negative square root 2 V3 over negative square root 2 minus I. Correct? No response.
Correct.
Yeah. So I don't want to divide. When you divide, then you have to multiply by square root 2 plus I over square root 2 plus I in order to get not complex number at the bottom. Okay, so I want to avoid that. So since I want to avoid the stuff, I purposely put this this negative square root 2 plus I. So because of this I put square root 2 plus I. and this is 1 minus I square root 2. Because square root 2, I choose 1 minus I square root 2. So when this is a product, V3 is a product of these two, I know that V3 divided by square root 2 plus I is 1 plus I square root 2. That's the reason. Okay, so
Okay.
yeah. So you can see this V1 is actually square root 2 over plus I. From here, you can see. V1 equals to square root 2 V3 over square root 2 plus I. The negative and this negative cancel off already.
Okay.
Yeah. So because I choose V3 as I purposely choose V3 as what? Square root 2 plus I times by 1 minus I square root 2. Correct? See, I choose V3. Choose V3 as square root 2 plus I times 1 minus I square root 2. So this V3 is chosen like this. Because choose like this, then I can cancel this 2. And then I get only times 1 minus I square root 2, which is you multiply square root 2 minus 2
So doctor, the purpose is
I.
to become to clear the
So that,
denominator.
yeah,
Denominator
yeah.
become 1.
Yeah, so that the denominator is not a complex number, which you have to multiply again to remove the complex number from the denominator. Yeah, that's then why you choose V3 is like this. Even the where is it? Even V2, V2 is negative V3 over 1 minus I square root 2. Because we choose the V3 as the product of these two, now it makes it easier negative square root 2 plus 1 minus I square root 2 over 1 minus I square root 2. So you get, you see, cancel off. So you get uh, negative square root 2 minus I. It's just a trick so that you work and remove the complex number from the denominator.
Okay.
Yeah, that's the reason. That's why you choose the V3 as this. Because V1 is this square root 2 V3 over square root 2 plus I, and V2 is negative V3 over square root 2. So if I have the coefficient, this denominators, product of these two denominators, okay, then makes it easier to cancel.
Okay, doctor.
Yes. Okay. Okay. So I think that's it. Time's up. My clock is showing 10 o'clock. Can you see or not? My clock.
Yes, doctor. Doctor, for question tomorrow, for test tomorrow, how many question?
How many questions?
Uh-huh.
I haven't said the question yet.
Okay. So the test the submission test will be open from what time?
Question will be available from 7:30 a.m.
Until
So you all can download lah. So you can start early. You can finish early, 8:30. Then you got 20 minutes, half an hour to upload lah. You can answer from 7:30 to 8:30 or 8:45, and then upload. You can upload 9 o'clock lah.
doctor,
Yeah, I can give until 9:15. What do you think?
there is some request from the other member which can extra time for scan and upload. Maybe 9:30 a.m. There is some request from
The reason why I'm giving it from 7:30 is so that you can have 7:30 until 9 lah. Wake up early. Start 7:30 until 9. You're supposed to have 8 to usually 8 to 9. Then you upload from 9 to 9:30. Correct? Correct or not, Shafiq?
correct.
Yeah. But then it's not fair to the students who have another class at 9 o'clock. Okay? You understand? It's not fair. Some of the students have another class at 9 o'clock. So those
Yeah.
students, then they have to submit by 9 o'clock because they have to attend another class at 9 o'clock. So that is why I'm giving starting from 7:30. We finish at 8:30. Then all upload. Yeah. Submit in e-learn. Yes, correct. Submit in e-learn. The Meet means I can switch on this Meet, the Google Meet. We won't be having Google Meet now. For easy questions.
Mhm.
The problem is every time I set easy questions, the students still say it's difficult. Easy question, the students still come up and say, "Oh, it's very tough." So I don't know. I cannot tell you now. Okay. Okay, yeah. 3:07 already. Bye. Should you open Google Meet during the test? No need. No need. I'll leave my WhatsApp on, then I will check my WhatsApp during the test in case any questions you all can ask through WhatsApp.
Okay, doctor.
Yeah. Yeah. Yeah.
Thank you, Doctor.
Okay. Thank you.
Thank
Then
you,
I can see my
doctor.
face. Okay. Thank you.